Good morning everyone, I am Avishek Mazumder and today in this video lecture we will be covering the topic how to balance ionic equations. Now ionic equations can be balanced in two forms. Either the reaction takes place in acidic medium or the reaction takes place in basic medium. The method of balancing ionic equation in both the forms are different. Now let's start with the acidic medium. How do we balance an ionic equation when it takes place in acidic medium? For that, let's take an example. Let's take a question that dichromate ion reacts with sulfite ion to form Cr plus 3 and sulfate ion. 2 negative. Okay. So now this is the reaction which we have to balance. Now let's check the oxidation state. In Cr2O7 negative, chromium is in plus 6 state, whereas in Cr plus 3 it is in plus 3 state. In sulfite ion, the sulfur is in plus 4 state, whereas in sulfate it is in plus 6 state. So the conversion from sulfite to sulfate will be the oxidation, and the conversion from dichromate to chromium ion will be the reduction. Now we break the reaction into two halves, the oxidation half and the reduction half. Firstly, let's check the oxidation half. So we just write the oxidation half, that is from SO3 2 negative to SO4 2 negative. So the first step is, in the oxidation half we have to balance all of the atoms except the oxygen atom. So except the oxygen atom, the only other atom available is the sulfur. In the left hand side we have one sulfur atom, whereas on the right hand side we have got one sulfur atom. So it's balanced. Now let's check the oxygen atom. In the left hand side we have got 3 oxygen atoms, whereas on the right hand side we have got 4 oxygen atoms. So we add water molecules to the side which is deficient in oxygen. So in this side, we add a water molecule plus H2O. And on the other side, we add twice the number of H plus ions. So since we added one water molecule, we add 2 H plus ions in this side. Okay. So now when the atoms are balanced, we try to balance the charge. In the left hand side, we've got 2 negative charge, whereas on the right hand side, we've got 2 negative plus 2 positive, that is net 0 charge. So to balance charge, we add electrons. We add 2 electrons to the right hand side. So now this reaction is balanced atom wise as well as by charge. So now let's go for the reduction half. The reduction half. Now let's write down the reduction half. Cr2O7 negative to chromium ion Cr3 positive. Now like the last time, we balance all of the atoms except the oxygen. In the left hand side we have got 2 chromium atoms, whilst on the right hand side we have got only 1 chromium atom. So we add a coefficient of 2 so that the chromium atoms are balanced. Now in the left hand side we have got 7 oxygen atoms, whilst on the right hand side we have got 0 oxygen atoms. So we add water molecules to the side deficient in oxygen, that is in this side we add 7 water molecules. 7 water molecules. Since we added 7 water molecules on this side, we add twice the number of H plus ions to the other side, that is 14 H plus. Okay. Now we have balanced the atoms. Now we try to go for the charge. In the left hand side, plus 14 minus 2, that is plus 12. Whereas on the right hand side, we have got just plus 6, 2 into plus 3. So in order to balance that, we add 6 electrons to this side. That's 6 electrons. Now the charge is also balanced. Now since these both reactions are balanced in charge as well as by atoms, we see that in the oxidation half we added 2 electrons, whereas in the reduction half we added 6 electrons. So now we cross multiply. We multiply the oxidation half by 6, the reduction half by 2, and then we add the 2 halves. In other words, to simplify this reaction, since there's 2 and 6 electrons involved, we can cancel them and we can multiply the reduction half by 1 and the oxidation half by 3. So multiplying it, we get, first we multiply this by 3, so we got 3H2O plus 3 sulfite ions, 2 negative, plus. Now 14H plus into 1, that is plus 14H plus ions, plus 1 into chromate dichromate ions, Cr2O7 2 negative, will give now 3 into this, so 3 sulfate ions plus 3 into this, that is 6H plus ions plus 1 into 2 chromium ions plus 1 into 7H2O, that is 7H2O. Now we are not done yet, because, okay, so this should be a bit more clear to you. Okay, so now in the left hand side we've got 3 water molecules, whilst on the right hand side we've got 7 water molecules. So in order to make it a bit more simpler, we remove 3 water molecules from here and we subtract it from this side, that is 7 minus 3, which makes it 4 water molecules on the right hand side. Now in the left hand side we've got 14 protons, whereas on the right hand side we've got 6 protons. So we remove the 6 protons and we subtract it from here, so which gives us plus 8H plus ions. So now 3 sulfite ions react with 8 protons and 1 dichromate ion to form 1 sulfate ion, 2 chromium ions and 4 molecules of water. This will be the balanced equation of the above reaction. Now let's take another example to see how do we balance the ionic equation when the reaction takes place in a basic medium. Till now we did how do we balance the ionic equation when it takes place in an acidic medium. Now for that, let's take the second example, that when manganate ion, that is MnO4 negative, reacts with bromide ion, that is Br negative, in basic medium to form manganese dioxide and BrO3 negative. 3 negative. Okay. So now in manganate ion, the manganese is in +7 state. In bromide, it's in -1 state. In MnO2, the manganese is in +4 state. And in BrO3 negative, the bromine is in +5 state. So we see the transition from +7 state to +4 state will be the reduction, whereas the transition from -1 to +5 will be the oxidation. Now let's study these two reactions separately. Let's take the oxidation half. Oxidation half. Okay. So we write Br minus 2 BrO3 minus. Now similarly like last time, we balance all of the atoms except the oxygen atom. In the left hand side we've got 1 bromine atom, on the right hand side we've got 1 bromine atom. Now in the left hand side we've got 0 oxygen atoms, while on the right hand side we've got 3 oxygen atoms. Now this is the point which we have to keep in mind when balancing in basic medium. In basic medium, we add the water molecules to the side which has excess of oxygen atoms. In acidic medium, we used to add the water molecules to the side deficient, while in basic medium, we add the water molecules to the side which has excess of oxygen atoms. This side has 3 excess oxygen atoms, so we add 3 water molecules over here. And we add twice the number of OH minus ions to the other side. That is, since we added 3 water molecules over there, we add 6 OH minus ions over here. Now we have to balance the charge. In the left hand side we've got plus minus 6 minus 1, minus 7 charge. Whereas on the right hand side we've got only minus 1. So we just have to add 6 electrons to the right hand side. Now the charge is also balanced. Now we try to go for the reduction half. Reduction half. Now in reduction half we write the reduction half as it is, MnO4 negative to MnO2. Okay. So again, like last time, we balance all of the atoms except the oxygen atoms. On the left hand side we have got one manganese atom. On the right hand side we have got one manganese atom. So it's balanced. Now we try to go for the oxygen atoms. In the left hand side we have got 4 oxygen atoms, whilst on the right hand side we have got only 2 oxygen atoms. So we add water molecules to the side which has excess of oxygen atoms. That is plus 2H2O. And on the other side we add twice the number of OH minus ions. Since we added 2 water molecules, we add 4 OH minus ions on this side. Now since the atoms are balanced, we try to go for the charge. In the left hand side there is only minus 1, whilst on the right hand side we have got 4 minus. So in order to balance the charge, we add 3 electrons to the left hand side. Now the charge is also balanced. Now in the oxidation half we use 6 electrons to balance the charge, whilst on the in the reduction half we use 3 electrons to balance the charge. So again, like last time, we cross multiplied. We multiply the reduction half by 6 and the oxidation half by 3. In order to simplify the calculations, we simply, since they are a multiple of each other, we simply multiply the oxidation half by 1 and the reduction half by 2. So we rewrite the equation as 1 into 6 OH minus, that is 6 OH minus plus Br minus plus 3 into this, that is 6H2O plus 3 into MnO4 negative, 4 negative will give BrO3 negative, 1 into that, BrO3 negative plus 1 into 3H2O H2O plus 3 into MnO2 we multiplied by 2, so 2 into MnO2 similarly we multiply this should be 4H2O and this should be 2 into MnO4 negative, okay, plus 2 MnO2 plus 4 OH minus plus 2 into 4, that is 8 OH minus ions. Okay. Now in the left hand side we've got 6 OH minus ions, whereas on the right hand side we've got 8 OH minus ions. So we can simply remove this and subtract 8 minus 6, which is 2 OH minus ions. In the left hand side we've got 4H2O, whereas on the right hand side we've got 3H2O. So again we can remove this part and write it as simply H2O. So the reaction will be 2 OH minus plus MnO. So this will be the final balanced equation of this ionic reaction when the reaction takes place in basic medium. I hope my lecture was useful in clearing all your doubts regarding how to balance the ionic equation. Thank you.